Good afternoon and welcome to the CAMCO GibbsCAM Probing webinar, where we're going to show you how to add automation to your machining process with GibbsCAM Probing. In this webinar, we will highlight a number of things, and this will be different than most webinars that you've seen, where we normally are talking about tool paths and tools and clicking in certain areas and making tool paths. Today we are talking about probing your parts with GibbsCAM and integrating that probing into your machining. And what we want you to know is that your probe is not just an edge finder. It's a very powerful tool that you can use inside of GibbsCAM to bring a higher level of quality and shorter lead times to your machining processes. Things that we are going to cover in this webinar will be datum setting just prior to machining, critical part feature analysis, updating wear compensation values and work offsets on the fly, and then creating an inspection report after the completion of machining. At the end of this webinar, we will have a question and answer section, and we'll give you an opportunity to interact with us. Let's go to our first GibbsCAM file and have a look and see what we have. Here we have a part that we use as our probing training part. It has a number of different features. And the first thing that you will notice inside of GibbsCAM is that we now have support for probe tools, including ball tools, disc, cylindrical, 2D form, and 3D form tools. So we can support the types of probe styli that you use in your machine. The stylus that we currently have here is the standard 6mm by 50mm stylus that comes shipped on most all of 99% of machine tools in the United States. And the first task that we have in front of us is yes, we are going to use the probe as an edge finder. But let's explore, before we start doing some clicks, let's explore why we would want to create our probing data and integrate it in the program rather than to have someone manually probe this. Why do we probe? We probe because we achieve more throughput with your GibbsCAM, CNC machines, and Renishaw probes. GibbsCAM does use the Renishaw Inspection Plus software that is inside of your machine, and it does use your Renishaw part inspection and part location probe. It also increases automation and reduces human intervention and mistakes. We're not interrupting the machining cycle anymore to have someone come in and use an edge finder and possibly fat finger the wrong number in, and then we've cut the part incorrectly. The probe doesn't miss. Next, we want to introduce process stability and repeatability. When you integrate the probing into your machining process, the same thing happens from start to finish every time. You close the door, you push the green button. The probe goes in and finds the part very quickly without mistakes, and then the machining commences. Next, we want to help you reduce scrap, rework, and concessions to your customers. In this webinar, we will talk about cutter parameter update. In other words, we're going to employ cut, measure, cut technology, having the probe adjust our wear comps for us to get the part as close to print tolerance as possible. The next thing that we'll talk about is to shorten manufacturing lead times. Because we are no longer interrupting the machining process to either reach inside of the machine and measure something and then type a number in and possibly type it in wrong, we're going to let the probe do this for us. The probe is a very accurate measuring tool. The standard Renishaw OMP40 and OMP60 probes have 10 millionths, I beg your pardon, they have 40 millionths accuracy. The OMP400 and OMP600 strain gauge probes, which are actually CMM probes modified for machine tool use, they do have an accuracy of 10 millionths of an inch. So this is not just something that lurks in your tool changer waiting to come in every once in a while and edge find a part. This is a decision-making tool that you can use to put intelligence in your programs. And lastly, we want to help you increase your process capability and traceability. Your process capability is directly related to how close your parts are to the middle of the tolerance. Now that we've identified a little bit about why we probe, let's talk about the how do we probe. Here we have a part sitting in a vise, and the machine type is going to be a 5-axis vertical. You can see where our 0 point is here on the corner of the part, and we have several machining features. What we're going to do here is we are simply going to datum this part. Yes, we're going to perform the edge finder function. Let's have a look at how it works. We have a process already built, and I will start this over again, but we wanted to show you what it looks like. We're going to program the Z-axis from the positive side, and then we are going to probe an outside corner from the lower left-hand side. Let's throw away these two operations and start over from scratch. And let's talk about data types for probing. For the Z, all we need is a point right there on the part. We bring the probe down into the process list just like we normally do with any other GibbsCAM process. And now the process menu opens and we will select, in this case, shapes. And cycle type will be single surface. The single surface selection is X, Y, or Z. We of course want to do Z. We want to tell the probe to stop 1 inch above the part. That's so that the operator can put the machine into single block and verify that 1 inch dimension before he allows the probe to start working on the part. But don't worry, from inside of this 1 inch dimension, the probe will be in probe protected mode. And if you remember this from your programming of the Inspection Plus, it's G65 P9810. And we are going to set work offset number 1 in your machine. Single surface, set work fixture, stop 1 inch above the part. Let's feed at 50 inches onto the part, and we're going to set G54. To touch, our standard clearance before we start probing is 0.4 inches. And that is one of the numbers that is a standard number inside of Renishaw Inspection Plus. Our probe depth in this case, we want it to find and set Z0. So now, whatever the probe comes down and touches, that will be set to Z0. If I set this to Z plus 0.02, when it encounters this point in your machine, it will set the top of that surface to 0.02. But in this case, we're going to set it to Z0. Now that we have selected the point and the machining coordinate system is correct, all we have to do is press do it, and there you can see the probe cycle is completed. Let's look at it in Machine Sim so that you can see what it looks like in your machine. This is the new DMU75. You can tell because it has the round enclosure. We'll go through this in single block. Next feature, there is my 1 inch, and now we go to 0.4. And we feed onto the part, we measure the part to touch, and then we are done. What happens inside of that cycle is, let's look at it inside of the posted code. Your GibbsCAM post processor will need to be modified to output the Inspection Plus code. As you can see, the program header looks normal, and in it, in this case, you will see a tool list and you will see a WFO list. This will become very important to us in just a few minutes when we start talking about probing on a horizontal machining center, where we might have 8, 10, or 20 parts inside of the machine. We have the normal machine startup codes, and we position the A and C axis. We call up the probe. We move into the first position where we're going to probe. Then we turn the probe on. The probes are a lot smarter than they used to be. The probe receiver now has the opportunity to look at the probe and tell if it's hot or not, which meaning that it's live. It has the ability to look at the probe and tell you if the battery is in good condition or if the battery needs replacing. Then we come into a, again, protected position move. We touch the top surface and we set S1, which is work fixture offset 1. Then we clear away from the part and end the program. We just set Z0, and we wanted to give you the opportunity to look at the code after it was output. The next thing we want to do is we want to set the X and Y of this corner to 0, 0. Again, we bring the probe down into the list, select shapes. This is going to be a corner. So let me back up a little bit and let's grab from the machining process toolbox this button called corners. That might be a better idea. Yes, we want to do an outside corner. We want to set work fixture 1. Yes, we want to stop at 1 inch above the part, 50 inches a minute. It's going to be a 2-touch, lower left-hand corner. It wants to know how far from the corner do we want to probe, 1 inch by 1 inch, and how far down on the part do we want to probe. And at this time we said minus 0.5, but let's push the do it button and see what happens. Does the probe cycle look like it's in the right place? No, it doesn't. So we need to adjust this Z distance. Can we use our Alt interrogator? Yes, I have that now set as Z minus 1, redo, and you can see that the probe is now probing correctly on the part. And yes, we still have Alt interrogator functionality with the probing. So this is a fully integrated, this is not a plugin, this is probing is fully integrated into our GibbsCAM. And as you can see, the clearance that we have here on the corners. Let's go to Machine Sim and watch the rest of this cycle run out in go mode. We won't single block through this. We found the top of the part, we found the Y, and we found the Z and the X. Now we need to move that down just a little bit because it put the center line of the probe. It showed us that we made a mistake. So this line is the bottom of the probe. We want to move it down just a little bit, and let's move it down another 1/8 of an inch since we're using a 6mm probe, which is roughly 1/18. I gave it another few thousandths, and we're now at minus 1.125. Let's watch this very closely here. Here comes the Z, there's the X, and there's the Y. So this exercise is complete. And now it is stored in your machine, in your program forever. Whenever you go to run this program again out on the machine, you have the operator preset the 0 one time, and then every other time the probe goes in and does the work. Here we have operation 1 and we have operation 2. If you recall from your Renishaw programming manual, 9816 was to find the corner on the part. So this is the first exercise that we've done, and it is called datum setting. What resources do we have for you to be able to understand the hows and whys? Let's go look at some documents that we have here, and let's look at AP10 productive process patterns. Some of you are familiar with step files, but you're not quite sure what the step program is. The step program is a program of CNC process management, and we show you how to effectively and easily manage your CNC process from the right direction. Many customers wait till the parts flow out of the top of the pyramid, find out what's wrong with the parts, and then work backwards down the pyramid to correct whatever's wrong with the process. With this documentation, and you will be able to send us an email, you'll see at the end of the webinar, you'll be able to email us and get all of this documentation to show you the how, the why, the problem, the solution, the benefits, and we'll show you an example of each type. We're going to show you how to manage your process from the foundation out using predictive controls applied just before cutting, and that's the datum setting. And then we're going to move quickly in just a moment to active controls applied during metal cutting. What are probing things that we can do while the door is shut and we're inside of the machine? And the last thing that we will talk about is when you're done, we want to measure the part and we want to create an inspection report or have the operator review some key dimensions. So we slip to the next page and we look at productive process patterns. These are things that you probably did not know that you could do with your probe. And let's look down this column right here, and the step is laid out in application protocols. No doubt you have seen step AP203 on your GibbsCAM import list, and step application protocol number 203 is about setting up the job. How do we do it? How do we do it effectively? And how do we do it exactly the same every time? If you look down this list right here, these are all things that we can do with our inspection probe. And in the first version of GibbsCAM Probing, we can do AP203, job setup. And then we can also do, let's go down here and let's find, here we go. We're looking for cutter parameter update, AP301. And then we have dynamic remachining, AP302. Thermal correction machine drift, AP303. And then at the end, we have AP403, critical feature reporting. So these are all activities that you can do inside of your machine with the door closed. With your purchase of GibbsCAM Probing, you will get these step application protocol sheets that tell you what the problem is, what the solution is, and what the benefits are, case studies, and here at the end, what will the code look like when it comes to your machine. We're just going to take a quick look at this step application protocol 203. We're not going to read all this, but instead of having the operators manually calculate the numbers, and operator skill and consistency can also cause a variation, step AP203 allows us to automate our datum setting just before cutting. Let's move on to the next file, file number 2, and it is still about AP203 datum setting, but we're going to expand and move into multiple work coordinate systems. As you can see here, we have a horizontal machining center. Let's let you have a look at the machining center with the pallet and all of the parts on it so that you can get an idea of what our goals are here. We have a part in this machine and it has a coordinate system on the front, a coordinate system around here on the right, and a coordinate system around here on the left. And we want to create an automated probing routine that will find this part. This part has been located in the machine and it has been accurately machined and squared up. Therefore, each one of these needs to be probed because this is a very accurate part. Again, we talked about geometry for probing. We can use lines or we can use points or squares or circles. Let's look at how we did this particular one, and we're still on step application 203, datum setting, but we're now in an HMC with multiple coordinate systems. Coordinate system number 1 is going to be the front coordinate system. That's going to be G54. Coordinate system 2 is going to be XY right, G55. And coordinate system 3 is going to be, XY left, G56. Let's show how we set these up with the probe. In the probe, everything looks just like it normally does. We're going to do a single surface here. Set work fixture X from negative side. Yes, we can choose where and how we want to probe with the GibbsCAM probing. And yes, we have selected the correct machining coordinate system. We did stop 1 inch above the part, and we're going to go a ½ inch below the edge of the part. Let's look at op number 4, which is going to happen over here on this coordinate system, X, Y, right. We did exactly the same thing. We set a single surface in the X from negative side. You've seen that happen before here. And then finally, over here on the left-hand side of the part, we have another coordinate system, and we have Renishaw Productivity Plus, GibbsCAM Probing, and Renishaw Inspection Plus working on the part all at the same time together. Yes, we have created a closed loop with your machine control and GibbsCAM and your probe, and that closed loop allows very, very accurate locating of the part without having to rely on the operator skill. And of course, if you're running lights out machining and you have a pallet pool feeding this machine, all of this probing happens automatically, and those coordinate systems are firmed up. So we have completed that. And now let's go back and look at, we're going to talk about a little bit more text. We talked about why we probe. Now let's expand those ideas just a little bit. What resources? We talked about the resources, the Renishaw Inspection Plus software and manual that came with your machine, the GibbsCAM and Renishaw step application protocols that you will receive in the email. And each of those step application protocols tells you how to do something. Your problems are daily simply this: inconsistency due to variations in your program cycle due to interruptions. Anytime you stop the program to either measure the part or make an offset, you have created variations that can affect the quality of your parts. The solution is add probing cycles and integrate them with your machining operations to create a green button process with consistency and stability. Now, the big one is, what are your expectations? What are the real tangible benefits of doing this? Number one, you will increase part quality by letting the probe interact with your program to create more accurate parts and reduce scrap. This works on small as well as large batch processing, even if you're creating one part. Work within your machine's accuracy capability to tighten your output tolerances. If you have found that your machine has an accuracy capability of 4/10,000ths of an inch, this probe system, the GibbsCAM probing system and Inspection Plus inside of your CNC machine, can help you get your parts within that capability. We're going to expand this file just a little bit by going to the third one, where we have converted it into a Tombstone Management System file. Tombstone Management System is a GibbsCAM option that has tremendous benefit to you in that you only have to machine the one part, and TMS does the rest for you, including the probing. The probing is fully integrated into GibbsCAM Tombstone Management System. Let's go to Machine Sim and have a look at what's going on here inside of this HMC, or this is an EC400. We're going to watch this from the top because this is our best vantage point to see what's going to happen inside this machine. 2, 4, 6, 8 parts inside of this machine, and they all need to be located accurately before the machining starts. And as you can see, TMS is doing its job in sorting the coordinate systems so that as few rotations of the pallet are required to speed up your machining process. Somebody has to set these parts. Why not let the probe do it automatically and save time, and it doesn't make mistakes? Now, what about the probe accuracy and the probe maintenance. You should check the calibration of your probe based on your needs. It might be once a day, it might be once a shift, it may even be once a week or once a month. But once you check the calibration of your probe with your ring gauge, you know that you can trust it with your parts and you know that it will not make mistakes. If you have a lot of swarf or chip formation in your machine, you may also use your high pressure coolant or your high pressure air blow to blow off the probing area first before you start measuring. All right, let's have a quick look at this. And this is the exact same file that we had earlier, but we converted it to TMS. And the steps to convert it to TMS are very simple. We select Setup, Stock, and Fixtures. We select the stock body from the body bag. And as you can see, we've typed in the numbers here and we press set. And the stock automatically populates around the outside of the tombstone. Then we go to set up TMS and I clear all. And I'm going to clear all here. To convert this file to TMS, this is what we do. We're going to add 2 side coordinate systems. And this is going to be get CS, XY right, and OK. Oh, we got to go back and get the B. Let's open that and let's get the B. Look, it knows the B rotation of the coordinate system. And the probing code does retract and orient the pallet so that the correct face is pointing towards the probe. We've added the right coordinate system. We're going to add the left coordinate system now because we wanted that sorting to be proper. The front and sides were done normally. Now all we have to do is press group by tool, and we did a repeat zigzag plus B, and that's it. TMS is set up for this part. We'll watch it run one more time, and then we're going to move to our next section inside of the probing, which is, I'm not sure, it's either critical feature reporting or cutter parameter update. Again, you can see that it is minimizing the rotations. It is finding all of the axes and all of the coordinate systems and setting those for you. There's something else that GibbsCAM can do for you inside of TMS. When you open the TMS window, you will see that there is an info button here. And when you press OK, you can then print this info sheet to take out to the floor and give to your operator for setup purposes. And yes, your operator can manually set up these coordinate systems before the cycle even starts, or if you'd like to have this done automatically, contact your local GibbsCAM reseller and they will tell you how you can get in touch with our post department, and your post department can create these G10 commands inside of your program that will automatically populate the coordinate systems for you. But we wanted to show you this handy report that you can hand to your operator so that he knows what's going on inside of the machine, where the rotations are, and how many parts are in the machine, and how many work fixture offsets are in the machine. That is simply a part of TMS. And yes, TMS, as you can see, is fully GibbsCAM probing capable. We're going to click process, and we did minimize subuse, and there we go. All of the coordinate systems are there in the file. You can have the GibbsCAM post department convert these to G10s, and here we have the probing code. Probing code, probing code, probing code, and we want to go right to op10. So let's go down here on the right side and let's find op10 and double click on it. And it takes us right to the cutting code for op10. It's all been set, it's all ready to go. The probe did all the work for us. Let's move on to the next part file right now, and let's go to cutter parameter update. This is number 4. What is cutter parameter update and what does it do? What we want to introduce you to is something that you may not be aware that your machine tool can do. In other words, there's a closed loop now in your machine tool where we can perform cut, measure, adjust, cut technology. What we did here, we roughed out the bore, and then it was roughed out before we got it. And then in op1, we semi-finished that 2-inch bore and left 5 thousandths on the inside of that bore. So it should be reading 1.9950. Then we took the probe in right after we did the semi-finished pass with your finished tool. We took the probe in, we set the data, we told it to not set a work fixture, but take a measurement of that bore. And if it's undersized by 10,000, don't worry about it. If it's oversized, then we want an alarm because the part cycle may be long and it may be extensive. And if the part is already oversized, we don't want to continue machining on it. So the probe is now making decisions telling your operator that, hey, this part is okay, or hey, this part is not okay. So what happens here when we select measurement? Let's watch it run. And then let's discover what happens inside of this part file. We do a semi-finished pass with the finished tool, and we leave 5 thousandths in the part. We told the probe to expect to see 5 thousandths, that 1.995. And then the probe automatically, because we told it to measure, it automatically took the output from the deviation of that 5 thousandths. Let's say that it was actually 4 thousandths. Then the probe would automatically update the wear comp for tool number 1 with that 1 thousandths deviation. And then in op 3, we go back and take the final finish pass. Now, we're going to have to go back over that again because it requires a little bit of explanation. Semi-finished pass, probing. We probe the bore, but as you can see here on the end of the 9814 line, there is no S value. The S value would normally set a work offset. But if you insert a T2 here, then GibbsCAM Probing and Renishaw Inspection Plus will automatically take the deviation of whatever that 5 thousandths should be and whatever it actually is, and it will add that to the wear comp of tool number 2. Just by adding this T2 to the end of that line, we updated the wear comp for the probe, and then what did we do? We came in and did a final finish pass. So this is astounding. This is called cut, measure, cut technology. We also refer to it as dynamic remachining. The probe and the cutter and the machine are all working together to give you tighter tolerance parts. Again, that is cut, measure, cut technology. Let's watch it happen one more time before we go to the next section. Cutter parameter update. And we'll go look at the application protocol for that as well. Cut, measure, update the tool, and then bring the tool back in and cut that part to final size with as tight a tolerance as we can get. Here's something that we have found out through practical application among our customers is that by using this method, if you have a machine capability of 4 10,000ths, we have found that you can generally hold that capability or just a tiny bit inside, maybe 1 or 1.5 tenths inside by using this method. And the main reason is because you have created process consistency. Let's go look at the step application protocol for AP301 cutter parameter update. The problem, updating of cutter length and diameter offsets is usually carried out in one of two ways: manual updates provided by either somebody reaching up in the machine and measuring, or we had to take the part out and send it to the CMM lab, and now we've already lost it. So no, we want to do this right while the machine has the part inside of it. Automatic update using a probe. Measure the size of the feature, update the tool diameter, continue cutting with the new data. So now we have, again, a sheet of paper that tells you exactly how this works. Let's move on to the next part file in GibbsCAM Probing. We're on part file number 4. Let's go to part file number 5, which is critical feature reporting. All right, so what is critical feature reporting and what can we expect from it? When the cycle is complete, we want to measure the part for reasons of, hey, we want to know if it's a good part or not. But number 2, we might even want a printed piece of paper. We might be an ISO certified company. And if we are an ISO certified company, we can then take and create a data report directly from the probe results. And that's what we're going to show you how to do right now, how to get the data out of your machine. All right, so let's have a look. We have a little bit of probing going on here, and let's see what's happening inside the machine. Well, nothing right now because there's no part in a fixture. So why don't we select those before we go to Machine Sim. Now we're back in the machine, and this is a Doosan DVF 5000, and the part is sitting right on the fixture on the table. This is a high repeatability fixture, and the part is located on this measuring fixture, or it could be the machining fixture. We found the bore, we found the X and Y of that pocket, and wait a minute, what just happened there? What did we do here? This part has a groove down inside of it. And yes, GibbsCAM does support disc style and other shape styli that you can use to probe different features inside of your machine. And here we have 3 different probing paths. One is probing a bore. The second is probing this rectangular pocket. Let's have a look at those. We are inspecting them. So yes, we're going to select measurement only, not work fixture. We have measurement, and we have an upper and a lower alarm set at 1,000 because the tolerance on this part is a 0.5 So immediately, if we get an alarm, the machine's going to stop and say, hey, this part's out of tolerance. There's no point in moving any farther. Or if it's undersized on the bore, there's something we can do about that. So here we did a bore cycle, and the bore cycle is simply one of our cycle types. Single surface, rectangular pocket, circular pocket, rectangular boss, circular boss. We selected circular pocket, and yes, we get to tell it exactly where the probing happens on the circle, because not every circle is complete. You might have a gap in this circle, but one of the things that you must know about probing circles is that for accuracy, you must have at least 185 degrees of material to get a good number. But since this was a full circle, I selected 0, 120, and 240. And there you can see the probe cycle measures the inside of that bore, and it outputs the measurement to your machine where you can go and look at it. Now that in itself requires an explanation. Where does the data go when it flows out of the probe? To do that, we must look at our Inspection Plus programming manual. And you have this manual in your shop, and it tells us exactly where the data goes. We just measured a bore using the 9814 cycle, and the size of the bore goes to, in your machine, macro variable number 188. The X position center and the Y position center also go to X position and Y position 185 and 186 for a bore boss cycle. And all of these other dimensions can be viewed by your operator. But there is another trick. There is a way that you can get the data out of here, because your machine can only hold one measurement record at a time. It doesn't have multiple registers to hold multiple cycles and their measurements. So as you can see here, we at Camco have created a little applet for you, and you'll be able to download this applet from our website. And the applets will be for FANUC, they'll be for Okuma, and they will be for Siemens currently. And as we expand our repertoire into post-processors, we will expand the applets into those as well. This is a little applet that creates an inspection report based on a FANUC control or a Haas control. They use the same thing, and it can create a file inside of your Haas control, or it can spit out the code through your RS-232 port to your DNC system. And all this code is called dprint. And we formatted this little applet for you to give you the nominal diameter of the feature, the actual pound 188, the deviation upper, the deviation lower, and is it in tolerance, yes or no. And at the end of the day, your inspection report, if you're a whiz at Microsoft Excel, you can make it look like this by creating your report using either CSV, if you're an Excel whiz, comma separated values, or TDL, tab delimited values. And yes, you can make a fancy report like this on your own so that you can have ISO traceability with your customers. Let's go back and look at what we did again. We measured a bore, a circular pocket. The probe depth was -3/4, and we talked about the 3-point bore boss. Then, because we can only hold one piece of information at a time, we pasted that applet in, a simple add Gcode op. And as you can see here by the post-process output, what's going to happen is it's going to measure, and then it's going to create a report, and then it's going to measure, and then it's going to append that report. It doesn't create a new report every time. It appends the current report inside of your machine with the new information. And something that we want you to know about this particular report is that it has time and date stamp inside of it. That's what this little thing is right here. This is time and date stamp. So it actually creates a report based on when that part was created, and then you can go back and look at the created report and tell if there were any infractions, and you might be able to tell what happened. But again, this is part of ISO traceability. And yes, we have probing, and we have a little applet that you'll be able to download from our website. And more probing, and there's the applet again. And more probing, and there's the applet in here. We will simply change the output register that goes into your machine. And this is called critical feature reporting. It's very, very, very simple to do. And it doesn't require but a few clicks. That's one of the things about GibbsCAM probing, is how few clicks it actually requires. The summary of today's webinar is simply this. The profit impacts of in-process probing are: in your part and tool setting, you can reduce your setup times by 90%. Probing is automated and more repeatable than manual methods. A more reliable setting process means less downtime once production starts. When tools are replaced, resetting will also be faster and less error prone. When we use the cut, measure, cut technology, the probe gets it right the first time. Now, with less process noise to deal with, and that process noise is stopping and starting of the process to either climb up inside the machine, or even, heaven forbid, shuttle the part out of the machine to measure it, and then walk around the machine, shuttle it back in, plug in some numbers. With less process noise to deal with, you are free to stop firefighting out on the floor and how to start make lasting improvements to your CNC processes. All this leaves you with better quality parts and more time to make them. And again, as you recall, this is not a plugin. It is integrated into GibbsCAM. It is a fully integrated part of the process, and it is also network shareable. Your post processor will need to be modified to be able to output the code. And the probing is a purchased option. And Mr. Bart Ehlers is going to join us now, and he's going to help us wrap up this presentation. Let's slip back over to our PowerPoint. And here we have the Q&A window. And if you have questions, you can enter them into the Q&A window on your screen. And now we have the live Q&A at the end of webinar. And I think I hear Mr. Ehlers.
Hey, Patrick, how you doing?
Fine, Bart.
Good job. Well, I'm good to hear. Glad to hear that. Hey, as usual, great job showing the functionality in GibbsCAM and in our new product, the GibbsCAM Probing. I think you clearly showed over the last 45 minutes that the probes are no longer just an edge finder. They're a lot more than that. Now using GibbsCAM Probing, you can get a lot more productivity. By using your on-machine probing, you can reduce error, and the probing becomes a critical tool in gaining immense productivity. So great job showing that. We do have a few questions, so I'm going to throw them out there, and between you and I, we'll go ahead and answer them. The first one we have is, can I still use my own probing cycles that I created in the past? I'll leave that one to you, Patrick.
Absolutely. Using the add Gcode function or the basic probing function, you can take your hard-earned probing processes that you've already created, and you can simply paste those into an existing program. And yes, they will be integrated into your cutting program.
Great. So we can retain legacy information, legacy work that the customers have done, and capture that with still using the new probing. So fantastic.
Absolutely.
You touched on this one, but I'll take this one right now. Does probing require a post upgrade? So the short answer is, like Patrick already mentioned, is yes, it requires an upgrade. Like anything else, whenever you want to add entirely new functionality to a post to support something brand new that it wasn't before, obviously you got to upgrade it. This does come at a cost, which we would quote to you along with the new probing software if you decided you wanted to wanted to add this. So that would be part of their quote, and that would be part of the process, would include upgrading your post processor. If you got any questions on that one, just reach out to the Camco sales team, and we'll walk you through the process of what's needed to upgrade your post to support probing. Let's see, another one. You did mention this, Patrick, but it is a question, so it's worth going over again real quickly. Can GibbsCAM Probing adjust tool wear compensation on the machine?
Yes, the GibbsCAM Probing, again, with the addition of when you post the code, go to the end of the line where that feature was probed and simply add the tool number at the end of the line. If it's tool 4, just add the T4 at the end of that line. In future versions of GibbsCAMs, this will be an integrated feature, but right now, add the tool number at the end of that line with T2. And if it is a Z probing feature, the wear comp Z will automatically be updated. If it is an X or Y probing feature on the diameter, the wear comp diameter of that tool will automatically be updated.
Okay. And again, if anybody has any questions on what Patrick is reviewing there, obviously we're just an email and a phone call away, and we can assist you with any of that to support that. Let's see. Next one, it's very much along the same line, so I'll let you take this one as well, Patrick. Can GibbsCAM Probing compensate for thermal growth in the machine?
Yes, GibbsCAM Probing can compensate for thermal growth inside of the machine. Thermal growth comes in a number of different varieties. Number one, you have the spindle growth. And number two, when you're on a C-frame machine, 25 years ago, we saw the y-axis growing on the machine, and we started to pay a lot of attention to the y-axis ball screw. But what we didn't realize, and we discovered it about 1997 or 98, is that because it is a C-frame machine and it's non-symmetrical, the C-frame itself, in other words, the spindle carrier, was actually growing away from the column of the machine in the y-axis. It wasn't the ball screw at all. But whatever the growth happens to be, whether it's temperature related or wear related, what you would normally do is you would put some type of an artifact in the machine, a toolmaker's button. And at the beginning of the process, you measure that toolmaker's button and you set it to a 0 condition in its work offset. You would set it to, say, the P199 offset on the machine, and you measure that toolmaker's button and you know that it's 0. In the middle of the program, if you have a very long cycle time on your program and you know you've got spindle growth, go back and measure that toolmaker's button. And if that toolmaker's button is showing that it's 1/1000th taller than it was, that data can be sent to the work offsets on the machine to adjust the Z-axis position of the work offset. And we can do the same thing with X and Y. So yes, there are a number of creative ways that we can compensate for machine growth.
Okay, well, that was a lot of information there. So again, I just want to remind everybody,
that was a big question.
We don't expect it was a big question and a lot of information. Absolutely right. But just wanted to remind everybody that you got any questions? Again, Patrick's a phone call and an email away if you need them. Hey, a couple more questions. This one is a follow-up to the adjusting the tool wear compensation. And the follow-up is, if we use tool wear offset comp, is there a way to return the tool wear to the previous value at the end of the program?
Absolutely. In the add Gcode, we're going to provide you with another little applet, because that's something that you want to do at the end of the program. Is you want to set the wear comp back to 0, and we'll provide you with a little applet to show you how to do that.
Okay. All right. We'll take a couple more and then we'll wrap this up as we're running up against our time slot. This is a good one. Do you support probing on lathes or mills only?
Yes, we do. We do support probing on lathes, but the lathe must have Inspection Plus software in it, and that includes the Integrex, the Multus, and all of those types of machines, the DCG style machines, the B-axis machines, where now they look like a welding machine got a hold of a lathe and a mill and stuck them together. So the answer is yes. If you have Inspection Plus, we can program those probes.
And to determine if they have Inspection Plus in there, you could walk them through helping them determine if they have it, and if they don't, point them in the right direction where to go get it.
Yes, just give me a call if you have a question about Inspection Plus. And what we'll do is you can walk your phone out to the machine. I'll show you how to look for it, and I'll show you how to bring the probe out and turn it on to check, make sure that everything's working okay. Because I wasn't joking when I said that a lot of people have probes lurking in the deep recesses of their tool changer that have never seen the light of day ever.
Yeah. Okay. Let's see. I guess we'll end on this question. Is GibbsCAM probing and NLO compatible? And I'll take this one, Patrick. So yeah, Patrick had mentioned this during the presentation, that yes, since it's a native GibbsCAM product, meaning we built it, we developed it, it's native in the product, that means it supports all of our licensing options as well, whether you're on a dongle, a hardware key, or a network license. So yes, probing can be added as an option to your network license. And again, if you want to find out more about that, just call Camco, the sales team, and we'll talk to you more about that. I guess that's all we'll take for now. There are a few more questions, but what we'll do is we have a list of these questions that we didn't get to, and we will follow up with you individually on those questions. So with that said, I'm going to go ahead and wrap up the webinar. Once again, Patrick, thank you for all the great information, and thanks to everybody for attending the webinar. And for the 100th time, just reach out to us if you got any questions, and if we can help you with anything, with any of your probing needs, because as you can see with the new GibbsCAM probing, we can really help you increase the productivity of manufacturing your parts, not only on the machine, but the data we can help you pull off the machine about those parts for your inspections further down the line. So with that said, thanks everybody. Everybody have a great day, and we will see you at our next webinar, which is scheduled for about a month from now, and that webinar will be on the new GibbsCAM wire EDM. So everybody have a great day, and thanks for attending.